Okay, so hello. This function, we need to check the increasing and decreasing minimum and maximum. The first thing is to find the critical values, and to find the critical values, we need to find the values where the derivative is zero or does not exist. So the first thing we need to find is the derivative of this one. The derivative, to use the derivative, I will use some trick. So if we have y equals x to the negative x. Usually you use the ln trick. Then this one you're going to be using some properties of ln here. We could say, remember that to the b is b. This one of the properties of ln or logs in general. This one is one of the properties. So here when we derive implicit differentiation, we derive both sides with respect to x. This one is going to be just y prime over y, right? It's the derivative of ln. And this one is derivative of product of two functions minus 1 because, minus 1. So f y prime is going to be y, which is x to the negative x, times negative ln x minus 1. Now we need to check whenever this equals to 0. Now let's see. So now, so let's see. So now, whenever how to solve this equation? This one equals 0. Now we have product of two things equals 0. One of them equals 0. So either x minus x equal to the minus x equals 0. And this one is impossible to equal 0. Could it be equal 0? You can think about this as x to the x. And for x values bigger than 0, this will never be 0. And for this one, we solve it. So we will have ln of x equals negative 1. And does this have a solution? Yeah, so x is going to equal 1 over e. 1 over e is our critical value. Now we need to check the sign of the derivative. So what's the derivative? Again, the derivative is x to the negative x, negative ln x minus 1. And we get that the critical value, one critical value, which is 1 over e, and this is 0. Now we need to check the sign of the derivative. So if I take any value bigger than 1 over e, say I could take e. How about if you take e here? If you take e, this one is going to be negative 2. So you can check testing values. So take e. If you check e here, so it's going to be negative 1, so it's negative 2, and this one is going to be positive, right? This is positive, so times negative, so this is negative. And how about the values here? What you can take here, for example, take 1 over e squared. Now ln of 1 minus 2 is just minus 2. So minus 2 minus, so here it's going to be 2 minus 1. And this one is positive because, this is always positive. In fact, for x is bigger than 0. When x is less than 0, this one is going to be messy. It's not defining. It should have a lot of problems. So x is bigger than 0. So here, this one is positive. So our function is increasing, decreasing. And surely 1 over e is a local maximum.